So we're going to start with Form 1. Please allow. To everyone, right? Yes. Okay. Yes.
Are we going to be able to modify our old test, or is it like a fresh test?
I'm still deciding that. Okay. If I can figure out how to make the latter work, I will. Okay.
I just want to memorize the answers.
So we got a lot to get through, so let's just get through it, okay? So we're starting with a class called word list. It's just designed to manipulate words. We have an incomplete class declaration, and it tells you what everything's supposed to do. So this is probably the most important part. You kind of want to commit this to memory, right?
Yeah.
So we have, let's do it like this. And that. So we have we're going to write a method called number of words length, and it's designed to return the number of words that are exactly a specified length number of letters, right? So if the word is a specified number of letters, we're going to add one to the count and return it. This is a simple count method. It's really not that difficult. You want to take a look at the solution for part A. So I'll go over all the parts with you. Okay, so we just create a count variable that holds the number of words, right? Then we loop through we check each word in the list by list. And if the list at position I, if the length of the word at position I is equal to the specified length that we inputted, then we're going to add one to the count. Once the loop completes, we return the total count. Questions on that one?
My mouse doesn't. I can't watch this. I can't watch it. Mine too.
Okay. So let me fix everybody's mice. Yes, everybody has non-working mice. Let's go. Let's try this. Try again. Good?
Yes, sir.
All right, we got it. Okay. So do we have questions on part A so far? Okay. Part B. We're going to write remove words of length. So remember that we have an array list, right? So our list of words is an array list, so it's pretty easy to add and remove stuff, right? So we're going to remove the lists that are of that length. The order of the remaining words is going to be unchanged. So here's how we do that. Since, whoops, I honestly think part A was just there to confuse you, because if we were using arrays, we would probably need a count so that we could set the size of the array. We're actually just using array lists, so it doesn't, I don't know that it makes a ton of sense. But we need a counter for the iteration. We're going to use a while loop because that just makes the most sense, because the outcomes of our if statements are a little bit more complex, and we only want to iterate forward under certain conditions. So the best thing when we're working with array lists like this, if we're going to be removing stuff, so when you get to the test on this question, remember first and foremost when you get to part B, remember that we're using a while loop because we're only iterating forward under certain circumstances. It's what while loops are really good for. So we're starting with a counter, and we'll just call it I for iterator, right? As long as I is less than my list.size, meaning we're going to loop through each value in the entire list, okay? If we have a word of the exact length specified, right, that's coming in as the parameter, if the word is that length at position I, then we're going to remove it. If it's not the specified length, we're going to move to the next word by going I++. Why don't we I++ if we remove? if we're removing a word or if we're removing a value at a certain position, right, all the other values shift to the left. So we're effectively iterating forward without doing I++. We're already iterating forward. If we add an I++ on top of that, we would actually skip one position in the array. Make sense? So if I have A, B, C, D, E, right? And I'm looking for B, and I find B and I remove B, C is now at the position where B was. If I iterate forward, I'm going to skip the C and move to D. So one thing's not going to get checked. Make sense? Do you have questions on part B? Yes.
For loop would work as well, right?
For loop would work. So if we use a for loop on this though, so if we said for int I equals 0, I is less than my list dot size I plus plus, right? What we'd have to do is if, so we'd have to go if the word at I has a length of len, right? Then we'd have to remove it. But since we're iterating forward either way, in addition to that, we'd have to go I minus minus to counterbalance the fact that we're iterating forward each time, no matter what. So the way that would look is if, so we do this, this looks the same. So that part looks exactly the same. The only difference is we got to throw up some, brackets and say I minus minus. Are we clear on why we have to do I minus minus there? Because we're not only adding I plus plus if we're removing or if we're not removing, we're adding I plus plus no matter what. So if we remove something, it shifts everything to the left, and then we have to say I minus minus to counterbalance the fact that we're going to add 1 to I when the loop runs again. Straight? Everybody good? All right. Question 2 on this form. All right, so we have a game called Token Pass. So what it does in here, what this is saying is I'm going to set up a board the size of the number of players. So each spot, there's going to be a player at each spot on the board, okay? Which is, I believe, an array, right? So we have this array called board. So these are the 2 instance variables that we need to keep track of when we're writing these methods. Okay. So the constructor is this guy right here, and I think that's part A. All right. So we'll go into more detail. You got to compartmentalize information on these as you go along. So if I'm looking at part A, right, I scroll around a little bit when I'm looking at these. And if I'm looking at part A, I know I'm writing the constructor. So all I'm doing right now is skimming through here. I want to definitely get a basic idea of how the token pass, the entire programs work. So you want to get like a bird's eye view of the entire program, but then you want to scroll back through and go, okay, what does the constructor actually do? So if we go through here, we can see that it just creates the array. So we already have the array here. We're definitely going to initialize it and set the number of values that we have, right? And then it initializes current player to a random integer. So current player means at what index is the player that we're going to perform some of an action on, right? Some sort of an action on. So all we're doing right now is initializing these 2 variables. That's all the constructor's doing, right? So we create a constructor. Here's our constructor. So we initialize board, and we set the length of board to the number of players, right? Again, each position in the array represents a player. Okay, it's the board is just a list of players. Okay, so then we're going to loop through the board, and we're going to set each value in the board to a random number between 1 and 10. That number between 1 and 10 is the number of coins that the player at that spot possesses. Okay, so the player at that spot is in possession of that number of coins. Then we're going to set a random number for the position of the player. So the current player is going to come into play later because it's part of the game. But we need to set we need to pick players at random, right? So let me just put that. So somewhere in the game, we need to pick players okay? So current player is a variable that we're going to set to whatever the current player is that we've selected, or the position of, okay? So that's all we're doing in the constructor. Does that make sense so far? Anybody have questions on that? All right, so part A done. I added some notes to this, so I'm gonna make sure I pass those on to you guys.
Those will be on your website, like first review.
Presently, yeah, as soon as I can get it up there. All right, part B. So let's take a look at part B. So now we're going to go through part B, and basically what it's saying is we're going that player that we selected at random, right? We're going to take those coins away from that player, and we're going to add those coins to each of the. We're going to loop through the rest of the players and add coins to them one at a time. So if my player's at position 3 and he has 3 coins, I'm going to distribute those coins to 4, 5, and 6, right? Each 4, 5, and 6, the players at position 4, 5, and 6 are each going to get 1 coin. Questions on that part? So all we have to do is create a method that's going to distribute those, right? So I'll go through the whole process. So we're taking the coins from the player at a random position, right? So the number of tokens is equal to the value that we return from the board at the position current player, right? So the player at this position has some coins, and if I call this, I can set an integer to that value, right? So that's my number of coins. So now my number of, this is basically a swap variable, because we're actually then going to set the board at current player to 0, because we're taking those coins away, right? So we're temporarily storing those coins in a variable so that we can give them to the other players. It's a simple swap so far, okay? So we're setting integer I equal to current player. I should have probably written that down, but it's still the position, of the current player. That hasn't modified yet, right? So what we're going to do is, as long as I still have tokens, right? As long as we still have tokens, we're going to go to the next player. And if there is a next player, is basically what this is saying. then we're going to, or if there, as long as there's a, we're going to move to the player as long as there's a, as long as we're not at the last player. If this is true, right, then there isn't a next player and we start over from 0. So if I have, if I'm using player at position 3, right, and I have, and player 3 has 5 coins, and my array is only 5 positions long, right? I'm going to go 1, 2, and then I'm going to get to the end of the array, and then I'm going to start over at 0. Okay, so we set I back to 0 once we reach the last position in the board, and we still have coins left over, right? Then we just start again from 0. We add, either way, we're adding 1 to the number of coins of the player at that position, and we're subtracting the token that we just added from the total number of coins. Questions on that one? All right, that's part B. I'm telling you, if you have questions on any of that, please let me know. Let's go. Question 3. Question 3, Form 1. Hiking trail. When you look at all this, when you initially look at this one, all these graphs and charts and stuff are going to kind of confuse you, but this can be one of the easier questions on any form in this exam if you think about it properly. There's not really, the functionality of it isn't that complex. It's hard to put the idea of how it works into code form, but once you're able to do that, the actual functions are pretty easy. So a trail is a list of markers, right? So the trail's marked out at different points, and the trail from the program's point of view is essentially just an array of different markers. Okay, they're stored in an index, and they're different at each of the markers. We're storing an elevation in the index, right? So essentially, we just have an array of different elevations, and all of them put together equals the entire trail. Okay, and we're going to do some analysis. So we have the class trail, and there's our array, right? It's called markers. The array markers basically represents the entire trail. Okay, so we're going to input a few trail segments, right? So this inputs, and I'll copy the solution in here for you. Basically, we're trying to determine if a trail is level, and we determine if it's level by whether or not the difference in elevation between the start and the end, the start and the end of the segment, right? We check each one of those markers and the elevation changes between them. And if, as long as the maximum, so we find the maximum elevation and the minimum elevation in that trail segment. And if the elevation changes between the two is less than or equal to 10, then it's considered fairly level, right? So 10 feet of elevation, I don't know if you've been on a hike, but it's not that much. So if you go on, if you're headed into a segment of a trail where the elevation change is less than 10, you're like, okay, I'm going to get some rest in here. This is an easy level part of the trail segment, right? And some of you guys have been used programs like this that have actually worked exactly like this. There's a lot of, if you do a lot of hikes or whatever, there's software that you can use to track what you're doing and stuff and how much exercise you got, which I enjoy doing. So let's get into it. So we have variables for the max and min. You don't exactly have to declare variables for these. You can just use markers at start and markers at if you like, but it actually works better like this. So we input the start of the trail segment and the end of the trail segment. So these are just your markers on that array, right? So you have an array of markers, and you have two values that are in that list of markers, and you're deciding the maximum and minimum elevation so that you can see the total elevation change in the trail. So we got our max and min, and we just set them both to start at first. Okay, we loop through each one. So we start at the next value past start, right? Because we already know what start is. We don't need to look at it anymore, right? And then we go to the end of the segment. So we loop from the start to the end. That's not a big deal. If one of the markers is greater than the max that I've already set, right? Then it becomes the new max at any point. So through this entire for loop, at any point, if I find the marker that's greater than my max, it becomes the new max, right? If at any point I find a marker that's less than the minimum that I've already set up, then it becomes the new minimum. Simple max min function, right? We've done at least 5 or 6 of these in our labs. Okay, not anything new. So then we just check the difference. If the difference is less than or equal to 10, that means it's a pretty level trail, and we return true.
Yay.
Are we good?
Yes, sir.
Okay.
Dude, what was that 3?
That was question 3, part A.
Can we go to Mixed Skills?
All right. So I'm just gonna update your notes. And by the way, again, I'm gonna post these when we're done, so you guys will have them. Okay. So let's go with part B. Part B is a little bit more complicated, but it's not that bad. So we're trying to figure out if the trail is difficult. So what does that mean exactly? If we're trying to see if the whole trail is difficult, what are we going to probably loop through?
Elevation.
But what's our loop size at this point if we're looking through the entire trail?
Like a max.
It's probably the same as the length of our markers array, because our markers array contains the entire array, right?
Yes.
Or it contains all the markers in the trail. So our loop size, I'm thinking we're probably going to have a loop here, and the size is probably going to be the size of markers, right? So let's check it out. What's our job? Job is to find out if the trail is level. The trail's level if they're less than, or if the trail is difficult. Sorry, I'm looking at the wrong one. So we're trying to find out if the trail is difficult. And the trail is considered difficult if there are at least 3 or more elevation changes that are greater than 30 meters, right? So 3 or more elevation changes that are 30 meters or more means that the trail is difficult. So that's really not a difficult algorithm to go through. So all we do is we say, and again, I just don't like having you guys waste time watching me type, so I typed them out ahead of time. So we have a counter, right? It holds all the elevation changes that we're going to find in our loop that are greater than or equal to 30. We're going to check every marker in the trail. So we're going to go to markers. So we're going to start at 0 and go to markers.length -1, meaning we're looping through the entire array markers. Okay? If we check 2 consecutive values and the difference between them is 30 feet or more, then we're going to add 1 to the count of elevation changes that are greater than or equal to 30. There is an if-then situation that you can set up here. If, markers at I+1, you find out which one's the minimum, right? So you could do that. You could find out which one of these is the minimum and then subtract the minimum from the maximum here. I like to use since we don't need the actual minimum and maximum to reference anywhere else, we can just use an absolute value here, right? I can say absolute value markers I plus 1 minus markers I, right? If that difference is greater than or equal to 30, then we add 1 to the count. Sound good? Okay. So even if we subtracted these here and I get like negative 30 or negative 40, the absolute value would give us greater than or equal to 30. You guys get that, right? So now we've counted, by the time this loop exits, we've counted the number of marker or of elevation changes that are 30 feet or more, and then we return that count. Or we return true or false if that count is greater than 3. Questions? So everybody's going to get 100% on Form 1 so far, right? Everyone, well, that's not possible, sir. So
There will be one KC arrives.
Yeah, when the KC arrives, you get that 110%.
Not when Destiny arrives. When KC. Get the reference.
I still would like my birth certificate.
Sorry, sir.
This quiz is so really easy.
Sorry.
okay. Let's go. Question 4. Route cipher. This one. So there's one question, I think, on every one of these that I would say is just kind of borderline unfair, but I still want you to learn how to do it. So I'm going to teach, this is mostly why we're doing this. So this is that question in Form 1. So what we're doing here is we're writing something that we're encrypting a message. So we're taking an original message, we're breaking it up into blocks, and then we're flipping the letters around to change the message. This is essentially what it's asking us to do. So this right here, I'd get a block size, right, with the number of rows and columns. And then whatever portion of the word fits into this block is going to be my first block. And then if I have a second part of the word or part of the message that fits in another block and another block and another block until I reach the end of the word. And each one of those blocks are going to get encrypted and flipped around. Okay? So our first task that they're giving us is we're filling a block, just a single letter block, with 1 character strings that we get from our string parameter. Okay? Row major order. Again, if you haven't heard that before, it'll just be confusing. Basically, it just means the rows go up and down, the columns go left and right. Row major order. Okay? So it gives you some examples. Those should help explain things a little bit. If we do, we're going to need to take substrings of the input string that we're getting. Because we're going to have to break it up into individual characters and add it into our block array. So let's go over the fill block. It gives us pretty good instructions. Let's just try and work it out. In this one, in the explanation here, I copied in the instance variables that you have to keep track of. When you're on the test, you do have the ability to copy and paste instance variables. I would definitely suggest doing that for most of these questions. So I just did this. That way I know what I can use to keep track of my different values, right? So if I'm filling a block, I'm going to need to keep track of 3 separate indices, right? One is going to be the index, the current index in my string. And then the other 2 are the rows and columns in my 2D array, right?
Yeah.
So start at 0 with everything. Everything's 0. So I'm going to loop through the rows, and then in each row, I'm going to loop through the column positions. And if my string str that's coming in from the outside, if it still has another letter, right, as long as I is less than the length of that string, then we just add that string to the letter block at row column. Kind of a simple 2D for loop, a little bit more complicated with the if statement. If we run out of letters and we have to fill the rest of the letter block, we fill it up with capital A's. Make sense? And then either way, we're moving on to the next letter in str, right? I keeps track of the current index in str. I'm moving on to the next letter if there is one. Do we have questions on that? Okay, because I got a lot in emails and the other periods, and I think I covered everything. Correct. That I don't know that would replace being able to ask questions and get your questions answered. So, but you're welcome to take whatever approach you want to get it. All right, so I'm just going to do this to start off with, and then we're going to move on to part B. So now that we've filled the letter block, we're going to encrypt our message. So the block is filled. And remember, the letter block is an instance variable, so it's now filled and we have access to it. Okay? So we're going to pull in a message. Or actually, we're not doing that yet. Just remember that we have a letter block and we can fill it using fill block. Okay? So we have our string message, right? And we've actually also got these integers for the number of rows and the number of columns that are in our standard letter block, right? So we have a string message that's coming in, and then we have a variable that's going to contain the final coded message. Okay? As long as there's another letter in message, I should probably specify that here. So here, this while loop is going to say as long as there's another letter in message, right? Then we're going to set up a variable n that gives us the total number of letters that we have available, or letter spots that we have available in the block, right? So this is actually spots. So we have available spots in the block. Oh, that's not available. That's just the total number. So total number of spots in the block is n. We're going to, if the length of our message is less than the block size, right? We're going to set our value n to the length of the message. So in all other cases, what we're going to do is we're going to take enough letters, which is the value n. So we're going to take n number of letters from the beginning of the message and use those to fill the block. So here's how we do that. We already wrote that method, right? We wrote the method to fill an individual letter block. So we're just filling that with a substring from 0 to n from our original message. You guys have questions on that part? It's a tiny bit tricky. Now we're going to encrypt the block and add it to our coded message. So it tells you what the encrypted block does here, but we don't actually see the implementation. All we know is if I filled the block with something, right? and the current block that I have access to, because it's an instance variable, if I run encrypt block on it, I can just, it will flip the letters around and change that block of my text to an encrypted message. And I can just add that to my final coded message. Okay, we good so far?
Yeah.
Message equals message dot substring n. What we're doing here is we're removing the use block from the original message. The reason this works is because if I take a substring, if I use the substring method with a single parameter, it'll go from n all the way to the end of the string, right? So if I ended at n, right? So if I already use the part up to n, then I don't need anymore. So I need to remove the rest. So all I have to do is set message equal to itself from n to the end of the original message. Question? Okay, by the time this while loop completes, we have a final encrypted message, and we're going to return that. One, two. Copy that. Put it in part B. Again, when you see these and they're using a bunch of stuff that is coming in from the outside, but you know is part of the class, I would just copy and paste those values into the code window where you're working so you remember what you use for which thing. Let's see, part, is that it? All right, that's Form 1. Please let me know if you have more questions. Can I settle anything now on Form 1 for you guys?
Nope.
Got it?
Yeah.